ดี
สวัสดี
ค่ะ
ครับสวัสดีครับผม
Good morning,
morning.
ladies and gentlemen.
Good morning. How are you guys doing today? Doing okay?
Welcome to the Sustainable Turf Grass Management in Asia 2018. My name Pontif from Major University.
My name is Lee Singhorn, AGM from Summit Green Valley Chiang Mai Country Club. We would like to be honored to be MC today. Okay. I would like to extend a warm welcome to all of you this year's conference.
The conference consists of 2 days, two full-day seminar at this Dusit Thani Pattaya hotels, and also have the field day, the AGAF Turf Grass Management exposition at Lam Chabang International Country Club.
Again, this year we have many collaborations that help organize this conference, such as the RNA, the Thai Golf Course Superintendent Association, the Sport Authority of Thailand, AGIF, and all suppliers and partnerships who will join us later on at Lam Chabang International Country Club.
The seminar topic this year, we will focus about soil fertility, stress management, and the best practice for turf disease and weed control, and also give you the key success of a tournament preparation. This is a good chance to learn all the best practice from our knowledgeable speakers.
I'd like to give you guys all warm welcome. Today, currently, we have over 200 registered delegates from more than 20 countries. I thank you guys for your participation, and hopefully the seminar will offer knowledge, insight, information, which all of you can apply in practical use.
Should you have any inconvenient calls, please feel free to contact our staff around you. Firstly, I appreciate to welcome Mr. Mesa Hanchai, the president of TGCSA. He is the superintendent at Brook Canyon Country Club in Phuket. He will have a speech for us. Ladies and gentlemen, please welcome Mr. Mesa Hanchai.
คณะผู้บริหารเจ้าหน้าที่การกีฬาแห่งประเทศไทยคณาจารย์ท่านวิทยากรคณะผู้จัดงานสัมมนาและสมาชิกผู้เข้าร่วมสัมมนาทุกท่านกับผมมีความยินดีเป็นอย่างยิ่งและขอต้อนรับทุกท่านเข้าร่วมการสัมมนาประจำปี 2561 ในครั้งนี้ในการจัดงานสัมมนาในครั้งนี้ทางสมาคมตั้งใจที่จะนำเสนอความรู้ที่สำคัญให้กับผู้เข้าร่วมสัมมนาทุกท่านและหวังเป็นอย่างยิ่งว่าทุกท่านจะได้รับความรู้และนำกลับไปใช้ในการดูแลบำรุงรักษาสนามของทุกท่านท้ายที่สุดนี้กับผมและสมาคมผู้ดูแลสนามกอล์ฟไทยขอขอบคุณทุกหน่วยงานที่ได้ให้การสนับสนุนและช่วยเหลือการจัดงานในครั้งนี้ขอขอบคุณวิทยากรที่ได้เสียสละเวลามาบรรยายและขอขอบคุณสมาชิกผู้เข้าร่วมสัมมนาทุกท่านบัดนี้ได้เวลาอันเป็นสมควรแล้วกับผมขอเปิดงานสัมมนาณบัดนี้ขอบคุณครับ
Please allow me to translate. Hello, board managers, Sport Authority of Thailand officers of Thailand, faculty members, guest speakers, seminar organizers, and all participants. I'm very pleased and welcome you to attend this year's seminar. This conference, the Thai Golf Course Superintendent Association, is hoping to provide important knowledge to all participants and hope that you will have the knowledge which can be applied to your golf course maintenance in practical use. Lastly, I and TGCSA would like to thank all supporters that provided all good support for this event. Thank you, all the speakers who have taken time to share experience, and thank you again to all delegates.
Thank you very much, Mr. Mesa Hanchai, the president of TGCSA. The next, I'm very great to announce for the next year's seminar, we already have a new partnership to join and willing to support our conference. So I will appreciate to invite Mr. Sumet Intamara, the representative of Thai Golf Course Association, TGC8. We support us and he will give us the speech today. Please welcome Mr. Sumet Intamara.
Sawasdee krab, ทุกท่านครับ The guest and President of Thai Golf Superintendents Association. Today I'm very proud that I joined this important seminar, which is the first time that Thailand Golf Course Association participate, or at least part of the seminar today. Some of you may know or may not know that we, Thailand Golf Course Association, is one of the association that founded by the golf course owners and also the top management who manage the golf course in Thailand. We founded more than 20 years now. Sorry that I have a little bit cold. Right now we have more than 100 members of golf course in Thailand. And as the association in Thailand, we have the mission and vision that to promote and to make the golf course in Thailand is more quality and top quality, which is one of the main talent for Thai golf course, which is, as you know, that the Thai golf course is now being the qualities and very good for the tourists and for the people who coming to Thailand and play golf. And this is one of the reasons that the Thai Golf Superintendent Association is very important to us, and we can be part and coordinate each other more and more. Actually, we already done in the normal way already, but I hope that in the near futures and even more, Thailand Golf Course Association can be more support and help Thailand Golf Superintendent Association to make it more successful and have more quality, which is, I'm very proud that today is one of the important seminar, which is can improve the technologies, equipment, and everything for the golf course. And I hope that this seminar will be made successful today. Thank you. Thank you very much.
Thank you, Mr. Sumet from DCCA.
Okay, before we start the seminar, I would like to inform you guys of the agenda for the next 3 days. If you guys look at in front of you guys, we have an agenda. Please follow along. We have passed the registration. Next, we will have our first speaker, Dr. Bill from University of Nebraska. The subject is soil fertility, stress physiology. Roughly around 10:30, we have a coffee break. Then again, after that, Dr. Bill will continue his speech. At 12 o'clock, we'll have lunch, which is next door. After lunch, at 1 p.m., we have our second speaker, Mr. Andrew McDaniel from Kenya Golf Club, Japan. Subject is tournament preparation strategies. Again, we'll have a coffee break around 2:15. After that, Mr. Andrew will continue his speech. Roughly at 4 p.m., we'll have Q&A. We'll be open for any questions and answers you guys have for our speakers. Today, we'll end the seminar at 5 p.m. At 6 p.m., we will have welcome dinner here at the Sitani Hotel. Tomorrow is a little bit different. We have field day tomorrow. Our buses will leave at 8:30. Please be on time, 8:30 a.m. We'll be leaving here to Lam Shabang International Country Club. The groups will be divided into two groups. First group will be field day. The second group will be going to the exposition by AGIF. And then lunch at 12. After lunch, we'll switch. The group that went to the exposition in the morning, in the afternoon, go ahead and switch to the next, the field day, okay? In the afternoon, we'll have a little mini golf game at 4 p.m. Follow that, at 6 p.m. will be dinner at the country club. On the last day, Wednesday, March 14th, we'll start the speech at 9:30. Please be prompt at 9:30. Our speaker is Dr. Lee Miller. Subject is turfgrass diseases and weed control. Coffee break around 10:30. Continue with the speech and lunch at 12 p.m. Following lunch will be Q&A for all delegates. Okay. Wednesday, we'll have a little thank you speech before ending the seminar. Other than that, please enjoy the first speaker.
The first topic, we will start the seminar on the soil fertility stress physiology by Dr. William Bill Kasher. I introduced him a little bit. Dr. William graduated in PhD horticulture from Cornell University, New York, and now he is an assistant professor and extension turfgrass specialist, University of Nebraska. He goes background in horticulture, specialized for soil science, and he will take and share the practical implement of soil fertilities and best practice for turfgrass physiology stress. Ladies and gentlemen, please warm welcome Dr. William Bill Kasher.
All right. Good morning. I'm Bill Kreuzer from the University of Nebraska in the center part of the United States. If you're not aware of where Nebraska is, you imagine the United States, the dead center of that country is where I am. And a little feedback. Today we're going to talk about some of the things that I study and focus on a lot, and that's managing growth. And how do we manage growth? Why is it important for us to think about growth? What are some of the tools and ways that we can become better growth managers? And so we think of ourselves as being turf managers, but ultimately we're growth managers, and we're trying to maintain some certain level of growth so that grass is going to be healthy, but it's still going to perform in the way that we need, so that our golfing clients are getting what they need from that turf grass. So we'll talk about some of the factors then that are influencing the growth rate of our grass, and then how do we use those factors to achieve the growth response that we need for our clientele. So we'll talk about soils today, soil fertility and soil testing. We'll talk about the environment today. How is the solar intensity, or how is water and mowing practices and temperature impacting the growth response that we see from our turf grass. We'll talk about fertilizers, particularly nitrogen fertilizer, and how we can use nitrogen fertilizer. And then ultimately, how do we slow growth down? Maybe if growth is just going a little bit too much, how do I reduce that growth rate? And so we'll talk about some of the plant growth regulator technologies that are out there so we can try to suppress that growth rate. So here's my research farm right in Lincoln, Nebraska. Lots of different research is going on there, and a lot of it focuses on this topic. So everything I'm talking about today is things that I've had firsthand experience in doing research on. So why worry about growth? What's the big deal? Why do we think about growth? Well, it's for a lot of different reasons. Growth impacts is a function of how the plant is accumulating carbon and storing carbon and sugars and burning carbon. Growth is going to impact our nutrient requirements and our pesticide requirements. So if we're growing a lot, then we're going to need more nutrients to support that growth. Call that nutrient demand. We'll talk about that in a little bit. Pesticide requirements too. If we're mowing a lot, we're going to start mowing our pesticides off. So we're going to have to apply more pesticides to try to account for that. The other side, if we have too slow a growth, maybe we're getting some diseases because the grass isn't growing to its potential to be able to handle and to recover from those diseases. A big reason we manage growth is for recuperative potential, or traffic tolerance. We need to have a certain amount of growth for that grass to be able to handle the wear and tear that we're putting on it. And that can be from our mowing practices and from our cultivation, but it's also from our golfers. Just the wear and tear that we're seeing on the turf grass as a result of that. So that's a big one. If we don't have enough growth, then the grass is going to thin out, the quality is going to go down, it's not going to look as good, and then we're going to have some issues with growth. Growth impacts other things too, right? It also impacts the playability of a surface. We talk about green speed and how fast that ball is going to roll across that putting green and how that's impacted by growth rate and the succulence that is on our plants. So here's kind of a picture of grass that's actually growing. And this is something that kind of the joke is, right? It's like watching paint dry is a common joke. Is it being kind of boring and slow, or watching the grass grow? We can really see that the grass is growing pretty slowly here. But the thing I want you to realize and watch in this image is how is it growing? We're seeing the growth rate in clipping yield from leaves getting longer. They're elongating. It's like a balloon. You're blowing into a balloon and it's getting bigger and bigger and bigger. Those are like the cells of the plant. And so the faster that those balloons are elongating, the faster the growth rate goes on. So we're seeing that here. We're seeing clipping yield as one of our primary indicators of what our growth is, being a function of this rate of elongation. So when it comes to trying to track our growth rate, what is the optimum growth rate that we need? And it's something we're doing some active research on. We need to kind of figure that out. I'm kind of under the impression that you probably need a certain level of growth rate to maintain quality turf grass. It doesn't matter if you have 60,000 rounds a year of golf or if you have 600 rounds a year of golf. To achieve those growth rates, to maintain that healthy turf, you might need a lot more fertilizer where you get 60,000 rounds of golf. You might need more cultivation to prevent soil compaction where you're getting 60,000 rounds of golf. But ultimately, the growth rate that you need, I think, is going to be pretty similar. So this is an area of research that I think we're starting to get into a little bit more. It's just to try to figure out how much growth do we have. It's a practice that we've been starting to promote, and I know Micah Woods has been promoting for a while, about collecting clipping yield so that you know what the growth is. Think about how much labor you spend on weeding beds and using weed whackers and weed whips to clean up around bunkers or trees. Just lots and lots of hours. Or the amount of hours you put into maintaining bunkers. It's a lot of time. So don't you think it's worth a little bit of time to go and collect clipping yield frequently so you know what the growth rate is, say on your highest valued areas in your golf course, your putting greens? I think it is. And so trying to understand what that number means is really going to be important. Here's a slide of that. Here's a situation where I have a golf course fairway, and I have 3 different examples here. And I manipulated the growth rate with growth regulating hormones. So there's no difference in fertilizers or anything else. So in the top left, the grass is kind of yellow. This is where it's growing too fast. It's etiolating. It can't keep up with nutrient requirements, and it can't make chlorophyll fast enough. It's looking really bad. And it was getting nailed with lots of diseases because it was growing a little bit too fast for the environment. Then in the bottom right, we see a grass that's growing too slow. We put traffic on this, that grass is going to thin out and die. And then we have the top right, kind of right in between, the Goldilocks effect, where the grass is growing at a rate that's fast enough that we can maintain a nice level of growth of clipping yield to handle traffic but not be growing too much where we're wasting nutrients and we're having disease and we're having this bright green color. So, how do grasses grow? Again, this is something that seems kind of silly to think about, but it's important. So we have this new emerging leaf that's coming out of the crown. Here's our growing point. The plant is all the stems are right down here. This is where our meristem is. And our new leaves emerge right down the center of the whorl. And so the cells divide here at the beginning, and then they get longer and longer as those cells elongate. And so elongation growth accounts for about 95% of the growth rate of a grass. So you get all these tiny little cells at the base down here at the crown, and they don't really grow until we get that elongation growth. So again, thinking about like a clown balloon, where if you're blowing on that balloon, it's getting longer and longer. That's kind of what we're seeing with these plant cells. Ultimately, kind of the growth rate from another way of thinking about growth is from a sugar's perspective. And how is the plant making sugar to drive that growth rate? And so the plant is going to try to use photosynthesis to take carbon dioxide and water in the presence of light energy and convert it to sugar. And then we add nutrients to that sugar. We can actually build the plant, the plant storage organs, the leaves, the seeds, the roots, everything. And then when it's dark outside and we need some more energy, the plant can then burn that sugar to continue to drive growth rate. But the question here is, how closely linked are these two things? The plant's ability to make sugar is determined on things mainly temperature and water availability and solar intensity, how bright it is outside. But the growth rate part, again, is a result of this hormone, gibberellin, that has to be there that causes the plant to elongate. So how tightly are those two things connected? So kind of the growth rate part where we're having cell division on the bottom, that's happening based on some timing structures and some sensing that the plant is using to know how quickly to make new cells. And then we see these elongation growth. And so we're starting to understand and study what factors are producing this elongation. So what we're finding is there's a really important hormone in grasses or in all plants. It was actually found in rice. It's called gibberellin. Gibberellin is just this hormone in there that when you put it onto a plant cell, it makes it grow easier, makes it stretch out faster. So if we go back to thinking about a clown's balloon, if you had a clown's balloon that was really thick rubber and you tried to blow on it, it's going to be really hard to get that balloon to blow up. If we put that gibberellin on that balloon, though, if you blowed on it, it would grow really, really rapidly, so it can grow a lot faster. And so a lot of this elongation is happening kind of in the lower part of the leaf. And then above, in the top part of the leaf here, it's not really growing anymore. So all our growth is happening in this zone of elongation. And so different environmental stimuli, like nitrogen fertilizer, lead to a production of this GA hormone, and so then we see a big growth rate. So when we put nitrogen fertilizer down, we see a lot of clipping yields. And so again, that can sometimes be disconnected from the plant's ability to make sugar, and we'll talk a little bit about that later on today. So we have different factors that are going to impact our GA production. We're going to have things like temperature are going to impact GA production. We're going to have different light quality. If we have grass growing in the shade, that plant will make more of this important hormone, gibberellin, because it thinks it's going to try to outgrow the shade. Can you imagine a little grass trying to outgrow a tree? That's what that plant is trying to do. So the shade is tricking, the light quality in the shade is tricking the plant to make more GA. If we have reduction in water status, there's less water available, the plant's going to sense that and say, I'm going to stop making this hormone GA because I need to hold on to my water, and I can't just spare it and use as much as I need. So it reduces that GA level. Mowing practices also affect GA. If we start mowing grass really, really short, it actually grows faster because it senses, I'm growing too slow. I need to grow faster. I'm too low to the ground. I need to have more leaves. So we know that mowing can impact this GA production. Nitrogen fertilizer can increase GA. So the more we put nitrogen fertilizer on, the more this hormone gets made. We have a tool in our workbench, though, that allows us to kind of reduce some of these factors and control them. If we're making a lot of GA from, say, poor light quality and shade, or making a lot of this GA hormone because we over-fertilized by accident, or something happened from the soils that released fertilizer, and now it's growing like crazy, we have these plant growth regulators that can reduce that GA, so we can actually shut down that pathway and have a little bit less growth. So that's kind of what we see here. This is the pathway to make the hormone. Again, it seems overly complex, and I'm not trying to say to focus on any of these different parts here. Just know there's this yellow box here is this active gibberellin. If we put down a product like Primo Max on our turf, it's going to inhibit the formation of this gibberellin, just like we're damming a river. So if we just dam that river up, then we're going to be able to shut down that gibberellin production, which means we're going to have less growth, and that's why we see less growth from the PGRs. At the same time, if we add nitrogen fertilizer to the grass, what happens? This pathway starts to go at a higher level. It's like we're turning up the volume of the river that's going to the dam, or we had a big rainfall. That's like the nitrogen fertilizer being applied. So how do we balance nitrogen fertilizer with our plant growth regulators to achieve a growth rate that we want to achieve? We'll talk about that. So ultimately, I keep thinking about this in terms of like a car. So if we can imagine our clipping yields as kind of the speed that our car is driving, then we can become maybe a little bit better at understanding what factors are going to make our car go faster and what factors are going to make the car go slower. We're talking about what factors are going to increase the clipping yield, which ones are going to reduce the clipping yield, and then how can we manage those different factors to achieve the green speed or the clipping volume or the car speed that we try to achieve. So I took to get a picture to kind of show a gas pedal and a brake pedal in a car. And so we have our accelerator pedal, we have our brake pedal, and then if you have a manual transmission, then you have a clutch. And the clutch allows you to select different gears. So right, you have first gear, and in first gear, you can only go so fast. Maybe you can only go 20 kilometers an hour in first gear before you have to go up to a different speed or gear to go to a faster speed. And then we have our dashboard with our speedometer on it and our gear indicator that's kind of telling us, how fast is our car actually going. If we don't have a speedometer, we don't really know how fast we're going. We're just looking at every other car and just saying, I'm going kind of fast, I'm going kind of slow. If we're not collecting clipping yields, we don't have a speedometer. We're kind of doing it by what we just see. Like, I think I'm going okay today. But if you're collecting your clipping volumes and writing them down, now you can start looking at that data and use it kind of as a speedometer to figure out how fast are you going. So we'll spend today just kind of going through these various things. We'll talk about kind of the clutch and the gears first, then we'll talk about the accelerator pedal, and then we'll talk about the brake and how do we apply those concepts to managing the growth rate of our grass. So first let's talk about the clutch. These are kind of our environmental factors. And it's going to be a lot of different things, right? We go back to this. Things like temperature, mowing practices, light quality, soil, water, and oxygen status, soil nutrients, other factors like traffic. These are things we really can't control. I mean, we can't really control the temperature of our grass. We can't do very much depending on shade, especially if it's from buildings or trees we can't cut down. We can try to manage water. We can try to maintain there's enough oxygen in the soil for our roots to be healthy. But if we get a lot of rain from monsoons or something, then we're going to have a lot extra water in the soil. Or if it's really dry and we don't have enough water to apply, we're going to be a little low. And so the idea here is you're going to have different combinations of environmental factors that are going to have different levels of potential for that grass to really grow, kind of a growth potential. So if it's ideal temperatures and ideal soil moisture and great sunlight, our potential to grow is really great. So if you're thinking of this car analogy, that'd be like you're in the high gear, like you're in 5th or 6th gear. If you hit the accelerator pedal, that grass is just going to start growing like crazy. If you fertilize, you're going to see a nice big surge in growth rate. But then if we're in a situation where the gears are low, like we're in gear 1 or 2, maybe it's too cold outside, or they're not getting good sunlight, all of a sudden now you hit the accelerator pedal, you put down more nitrogen fertilization, you don't really see a growth response the same you would with a different gear. So let's talk about some of those factors. So the first one, we'll just talk really briefly about soil water because there's not enough time for me to go over this all in 2 hours. So soil water is a big factor, and this kind of shows what happens to a grass plant as you impose drought on it. So you're going from really short-term drought, within minutes to, say, season-long levels of drought. So in short-term drought, the first thing that happens is those plant stomata, these little holes on the leaves that open and close, they close. They want to hold on to their water, so they're not going to let any water escape the leaf. As a result, it starts making less of that hormone gibberellin, and so the growth rate starts to slow down. We see an increase then as some of the carbon, some of the sugar that would have made the leaves grow can now be repartitioned and removed to go down into the soil, to go into the roots, so now we can have bigger, deeper, healthier rooting. So we see during some mild drought, we see a carbon partitioning from leaves to roots because there's less of that hormone gibberellin there to waste carbon to grow leaves. And then ultimately over time, you know, eventually the plant starts to die off, but a little bit of water stress is definitely one way that we can try to reduce our growth rates. We are reducing the growth potential of that plant because it's got less water there and it's trying to conserve nutrients or conserve water, and but at the same time, we're not going to get the same amount of growth response out of fertilizer if we're in a kind of a droughty environment, which I think makes kind of sense. Here's some research that was done on carbohydrates, sugar partitioning in between leaves and roots when you had two different levels of irrigation. So the orange bars there show what the sugar levels in the roots looks like from June, July, August, September, and this is in a cool season grass, creeping bent grass. But it just kind of shows the idea of maybe a little bit of water stress and what it can do to help our plants and their plant health. So what we notice is from doing deep and infrequent watering, or counter to that, not even deep and frequent, just keeping the soils on the drier side. You could do light and frequent, but just keep the soils, you know, just above the point which the grass starts to wilt. By doing that, we see an increase in the amount of sugar in those roots. If our soil is not at field capacity, so it's holding as much water as it really can hold, and we water it, we overwater so that the soil has always got plenty of water, that might be great for promoting elongation of our leaves and the growth rate in our clipping yields, but as a sacrifice, we see less sugar in the roots because that sugar that would have went to roots is now going to promote leaf elongation and leaf growth. How about mowing practices? Growth rate, or mowing height is really a big factor on golf course turf when it comes to how fast grass grows. So here's some research that shows the clipping yields of grass growing at greens height, which is the blue line, or at fairway height, which is the red line, so your collar height, which is still even a kind of a low fairway. And if you look at what the clipping yields are, and the line goes from, on the bottom here, we have different levels of Primo Max. So the higher levels of Primo, we see a reduction in the clipping yield. But a thing that's really important to notice here is, look at how this blue line, the clipping yields on the green at the same level of nitrogen fertilizer and the same everything else, the same soils, they're growing at about 1.5 grams of weight per meter when we dry out the clippings. The grass at fairway height starts growing at only 1 gram. So our grass that's mowed higher is actually growing slower. Why is this? Well, if we're mowing a putting green really low, then all of a sudden the grass is like, hey, I don't have enough leaves. I need more leaves. So it starts to grow at a greater rate. And so we see a faster growth rate from our low mowed greens than we see in our fairways. So think about that when we're thinking about maybe your collars, and if your collars are getting worn out by all the traffic that's placed on them. What is going on? Why are your collars declining? Well, one of the factors is they're just naturally growing slower. So if they're growing slower, we don't see enough growth to handle that amount of traffic. So the green is growing faster. It's able to handle that traffic. It looks okay. But those collars, they're not growing as fast, and so all of a sudden we start to see some problems. How about growth frequency? So some different rationales are out there, and it came from some of the stuff my dad was talking about. My dad hates to mow his lawn. He just hates it. He hates taking care of the grass. It usually looks terrible. My dad was a police officer, and his partner loved to take care of his lawn, just loved it. And so my dad's partner would mow his grass like twice a week, his lawn, and then my dad would mow it like once every 2 or 3 weeks. And their rationale was, if I don't want to mow very much, my dad thought if you increase the mowing frequency, you're actually going to have, or My dad's partner said, if you increase the mowing frequency, if you mow more and more, you're going to actually put some stress on it because you're mowing it all the time, and it's going to grow slower. So that was my dad's partner's thought, the guy that likes taking care of his lawn. Then there's my dad's thought, if we scalp all the time, the scalping will put so much stress on that plant that will actually have less growth rate. So I wanted to kind of evaluate that. Traditional textbooks would say you want to always mow to the 1/3 rule. So when you mow, you always are removing at most 1/3 of the leaf at one time, never more than that, right? And that really hasn't been evaluated in any type of research. It's just been kind of one of those general rules that we've had for a long period of time. So we wanted to kind of evaluate that. So we had an experiment, cool season grasses, 2 or 3 inches. But the important thing here is we mowed it either weekly, or we mowed when we would remove 1/4 of the height of the grass at one mowing. We'd mow to the 3rd rule, or we would remove half of the leaf tissue when we'd mow it. So we'd pretty much be scalping. So we'd measure every day, and then when we hit a certain threshold, we'd go out and we would mow. So we counted the number of mowings. What did we realize? Well, weekly and the 1/4 rule resulted in more clippings. So we had to mow a lot more at that frequency. This is what my dad's partner is doing. He's mowing on this orange box here, so he's mowing a lot. And then my dad is scalping, so he's kind of in the yellow box here. And so yes, he's going to mow less, which is what he wants to do, is mow less. But again, the question was, which one is impacting the growth rate more? And then we have the ideal here would be our 1/3 rule, is kind of in between this one and this one. So we only had 14 mowings at 2-inch height and 11 mowings at a 3-inch height when we were mowing to the 1/3 rule. So what did our actual clipping yields look like? When we looked at the actual amounts of grass that we collected over the course of that whole year, and we've done it now for 4 years, what do we see? We see that whenever we scalped, it didn't matter if we were mowing at 2 or 3 inches for this tall fescue, when we scalped, we were actually growing faster than if we were mowing to the 3rd rule, or if we were just mowing weekly and just willy-nilly, I'm going to mow every single week. So this one is going to need more nutrients. It's going to burn sugars faster. It's going to look bad because we're scalping it. And so you can really see that although my dad got to mow less, he's putting a lot more stress on his plant for nutrients and for sugar because of how he's using his mowing practices. So in some of those conclusions, this is one of those cases where we actually showed that our general rule, like to never remove more than 1/3 of the leaf, is a good rule. That works out really, really well. That's going to provide the fewest number of mowings, the slowest growth rate, but also maintain good quality without having any type of scalping. So let's talk about some other factors in our clutch. So we have mowing. We talked a little bit about water. I'm not going to talk about light because that's a whole other topic. And I know for the warm season grasses, pretty much the more light you guys get, the better. So it's a little less complicated than it is even for the cool season grasses. But we won't really touch on that today for time. So let's talk about soil nutrient levels in our soil nutrition. All nutrients are important, okay? Micah, I saw your slide about you hating this slide, which is great because I use the exact same image here. All nutrients are important. But for the most part, the most limiting nutrient in a turf grass situation is nitrogen. And so when we think about other nutrients, the idea here is not to think of, do we have enough of this? If I add a little bit more calcium to the soil or more phosphorus to the soil, am I going to see some type of a plant growth response? And for our turf, that might kind of work in agriculture where you're trying to fertilize with different nutrients to hit yield. But we're not worried about really that much yield in turf. Our biggest worry is going to be on how's that grass look, how's it performing. And what we see is once a nutrient like phosphorus or calcium or potassium is satisfied, especially like things like phosphorus, once that's satisfied by the plant, it doesn't matter if you put more in the soil, the quality is still going to be about the same. And so if we want to have higher quality or higher growth rate, a lot of times nitrogen is the nutrient that's kind of holding things back. So this is that von Liedberg's law of the minimum barrel here, where if the nitrogen slat is the lowest, if I put more water in this barrel, it's just going to pour out. I can never fill it up to maybe the height of the phosphorus or the magnesium or the other nutrients that are there. And so that's an important thing to just kind of think about, that the nitrogen is really the biggest driver, and our soils are kind of the bank account, so that when we increase growth rate, if the plant goes into the bank account and it needs phosphorus, is there enough there to sustain that level of growth, to satisfy its demand for that nutrient? Because ultimately, the faster the grass grows, the more of all the nutrients it needs. It makes sense, right? Because those nutrients make up the leaves, so if the plant is growing a lot faster, I need a lot more nutrients to make those leaves. If it's growing slower, then I need less nutrients to make those leaves. And this is a slide from my mentor, recently passed away from University of Wisconsin, Wayne Cousseau. And he's really the one that kind of got us down this whole line of research. You know, it's something that we've been kind of now taking and running with. Me and Micah and Doug Soldat at Wisconsin. A lot of these concepts are coming from these things that Wayne Cousseau showed in the 90s. So if I have more growth rate, I'm going to see more nitrogen increase or uptake. I'm going to see more potassium, more phosphorus, more of every nutrient. But our nitrogen is really the driver of this. So if I put down more nitrogen, the plant senses that. As a result, it makes more of that GA hormone, gibberellin hormone again. It increases growth rate, and then it has to take up more nitrogen and phosphorus and potassium and calcium to satisfy that level of growth. So here's an example from more of Wayne's work. So this is a Kentucky bluegrass lawn, but these concepts, he did an analysis where they analyzed it in cool season grasses, warm season grasses. They transcend all grasses. Doesn't even matter the species. The more the grass grows, the more of every other nutrient it needs to take up to satisfy that growth. So if he put down 2 pounds of nitrogen per 1,000 square feet a year, this is the amount of tissue nitrogen, phosphorus, and potassium in the leaf. So if you go from 2 to 4 to finally 6 pounds of nitrogen per 1,000 square feet a year, we see an increase in the level of nitrogen, which you'd expect because we're putting down more nitrogen fertilizer. But we also have an increase in the amount of phosphorus from 0.42% to 0.48% in the tissue. And we see an increase in the potassium from 0.24% to 0.29%, just by increasing the nitrogen application rate, because nitrogen is driving an increase in growth, and we're seeing an accumulation, an increase in the amount of tissue, other nutrients. So this is an important point. We do not control uptake of that turf grass directly, of nutrients. We don't directly control it. The plant controls it. Plants are living organisms just like us. They don't have a brain. They don't have a brain that says, I'm hungry, I want to go into the pantry and grab a bunch of snack food today. But there's important chemistry that's going on. And on the root cell, we have all of these different proteins. These proteins are just little holes that can open and close. And each hole is specific to each nutrient. So there's a calcium channel, calcium hole transporter. There's a nitrate one, there's an ammonium one, there's a potassium sodium one. Those two are shared, but for the most part, they're all these separate little holes. So when that plant says, I need more calcium, do you know what it's going to do? It's going to go make some more of these calcium transporters, and it will allow more calcium into the plant. If the plant doesn't need any more calcium, it says, I don't need calcium. It pretty much shuts its mouth. It takes those calcium transporters and either turns them off or it just destroys them. So no more calcium gets in. So the plant is controlling what it needs. So if you want more calcium in the plant, you can go put 20 or 30 or 40 pounds of calcium down per 1,000 square feet. If the plant doesn't need it, we're not going to see a big change in the amount of those nutrients. The plant is being selective for what it wants. So here's an example of that. Here's a soil. He's going back to that Wayne Cousseau research. He's got his different fertility rates on this lawn. So in the first example, we have the tissue contents here. We have the amount of tissue nitrogen, tissue phosphorus, tissue potassium. When they fertilize with either 4 pounds of nitrogen, no phosphorus and no potassium. Then they had a treatment where they had 4 pounds of N, 1 pound of phosphorus, no potassium. Then they had 4 pounds of nitrogen, 3 pounds potassium, no phosphorus, and then they had a complete solution. And because nitrogen is driving growth rate, and all of those treatments had 4 pounds of nitrogen, the plant didn't need more phosphorus. It didn't need more potassium. So as a result, we don't see that there's more phosphorus in the plant because I put down phosphorus fertilizer. There's no potassium in the plant because I put down potassium fertilizer. The plant didn't need it. We didn't see that uptake. And that's because the soil was able to supply it. If we were deficient in phosphorus, if we put phosphorus down, we'd see an increase in phosphorus. We'd also see the grass would look bad. It would look deficient. So it depends on looking at our soil. And so if we think about our soil as more of a bank account, then the plants can then draw from when they need nutrients. Then it's one way to help us analyze and understand how we need to manage our soil nutrient levels and how do we interpret our soil tests. If we go back to this slide here where he had different nitrogen fertilizer rates, this is pretty interesting. Again, thinking about the soil as a bank account, if we're using the same fertilizer here, but we're using at 2, 4, and 6 pounds of nitrogen per 1,000 square feet, look at how the soil test levels changed. At 2 pounds of nitrogen, the phosphorus level dropped 6 parts per million over 3 years. The potassium dropped 25 parts per million over 3 years. We fertilized with 3 times that amount of nitrogen in that fertilizer. Now our phosphorus dropped 17 parts per million, and our potassium dropped 57 parts per million because the plant is taking it up faster. It's relying on that soil bank account. And so if I'm looking at this as a turf grass fertility manager, and I see my potassium drops 57% over 3 years, I'm thinking, you know what, I need to put down some more potassium. And focusing on the trends instead of on those individual numbers can be a lot more helpful in trying to figure out how to tie soil testing to our fertility records. So kind of in summary, plants control nutrient uptake, and uptake is a function of growth rate. So the more nitrogen that's there, the more the plant wants to grow, because the more N that's there, the more that hormone gibberellin's made. We see an increase in growth rate. It takes up nutrients to try to keep up with that increase in growth rate. So more nitrogen equals more growth, equals more nutrient uptake, which leads to a depletion in soil fertility. And again, if we can then start using our soil tests, it's kind of like a bank statement. I'm monitoring, how has my potassium changed over 3 years versus how much have I put down? If my potassium is continuing to decline and I don't want it to decline anymore, well, I got to put more fertilizer there. If my potassium is going up and I don't want to waste money on potassium, then you put down less potassium from year to year. So we can start to try to optimize the amount that's appropriate to your golf course. So we're trying to monitor soil tests as kind of our bank account status. So you might do soil testing, and for many people it's a very familiar process and it's overly confusing and complex. So the first thing you do is like, all right, I'm going to take a soil sample and I'm going to submit it to a lab. Sounds easy enough, right? Well, then you have all these questions. Well, how deep do I sample? Do I do 10 centimeters? Do I do 15 centimeters? Do I do 5? Does depth even matter, right? Then you think, okay, well, I've got these cores now, and on the top I have all that grass tissue. Do I take the grass off, or do I leave it? I don't know. Ultimately, we usually just say just leave it, because the lab will grind it up and the tissue will come off the top. Then you think, what lab should I use? There's a lot of different labs out there. They're all promising different things. They might promise different prices. Do I pick the cheapest one? Do I pick this certified lab? Do I pick this lab over here? And then you think, this is a lot, this is pretty expensive. You look at the cost, you're like, this is not really cheap. Is it worth it? Am I going to get enough value out of these results to really use them to save money at my course? So you decide to do it. You send it off to a lab that you like, that you picked. You wait for a while. Then you get a soil test report that comes back. And the first thing that I see every time I look at these stupid reports is saying, wow, there are a lot of numbers. There's graphs everywhere. There's different, ratios here and there, this versus that. And then I think, what do these numbers even mean? Is this really all important? Is looking at my potassium to magnesium ratio really that important? My calcium to magnesium ratio, is that important? Well, do I have salt issues? Like, your mind just goes crazy trying to understand what all these dumb numbers mean, right? So then you look and you see low somewhere on the report. So there's a word low, and then you think, oh, that's a problem. I got to fix that. But where did that come from? Who said that number is low? So you're looking at maybe you got a potassium test, and you send it into the lab, and the number comes back at 57 parts per million, and it says low next to it. What's the first thing that you're going to do? You're going to go out and buy more potassium, or you're going to figure out how to get more potassium in your soil. But you can send a sample to me or to Micah, and I'd be like, 57, you're probably fine. It's a good number. I wouldn't say you're low. You go to a different lab, they say, no, you're below 100. That's a problem. You're way too low, right? So that interpretation comes from people. It doesn't come from a machine, and so you can have issues that can arise from that. So then ultimately you say, okay, well, I'm scared now. I'm going to go buy some stuff. So a lot of times when people focus on the number of soil, on a soil test report, I'm convinced it is this like glorified, like you're paying to be fear-mongered too. Like I want to pay so I can be scared and go buy a bunch of things. Like that's what happens when people do soil testing sometimes. And so we're talking about today how to not do that. What should we avoid? How do we look at this number so that we're not intimidated by it, but that we can make good decisions on how we should manage our turf based on the numbers and the result we're receiving. Because I think soil testing has a lot of value. Again, it's like the bank statement. It tells us how much nutrient is in that soil. So when we look at our report, you kind of see this is typical anatomy. We have 3 different parts. We have results, we have interpretations, and we have recommendations. The only thing that comes from a machine is right here, the results. And yes, there's different methods and different ways to obtain these results, but honestly, there's probably less variability if you have the same certified lab using the same technology and the same, certified lab like a Mehlich 3 extractant, that this number is not going to move a ton. There'll be differences between labs, so pick a lab that you like and stay consistent with that lab, but don't try to go between all these different labs. But then you have these interpretations over here, and this is again where you say low, medium, optimum, high. I've always had a question with that. So if you had potassium or you had calcium, and it says optimum or high, which one do you want? Do you want to have high or have optimum? That was always confusing to me. I have a PhD in soils and fertility and in plant health, and I still can't understand what that means, especially in a turf environment. So let's just talk really quickly to understand our bank account and where is the nutrients distributed in our soil. So we have a couple different forms in our soil. So we have kind of non-labile nutrients, and these are nutrients that become available to the plant maybe never over the life of a plant or very slowly. So this is a situation where we have a clay. This is a clay particle. If you looked at it under a really good electron microscope, you could see all the different elements inside of the clay, and you'd see these little potassium molecules here, which is a plant nutrient, sandwiched between these sheets of clay, which are like oxygen and hydrogen and iron and different things that make up the various types of clay that exist. Then you have nutrients that are bound kind of to the outside of the clay. And these can become available to the plant, although they're slow. They're not instantaneous, but they're not super, super slow. And then we have what the plant actually sees. And this is what's in the soil solution. Plants drink their nutrients. As they drink up water to cool themselves off, the nutrient is moving to the roots. Then the roots say, oh, there's some calcium outside. I need some calcium. I'm going to take it up. Or there's some phosphorus here. I'll take it up. Or if it says, I got enough calcium, it's going to say, no, you can just stay outside my roots. I don't need any more calcium, okay? So that's going on here. We have 3 different forms. And let's use this into an analogy that makes more sense to, I think, people. So I think about this non-labile form as part of the rock. It's kind of like a retirement savings account. You might be putting money into a retirement account, and it's sitting there. You might have, $5 million in some retirement account. But you're not going to touch it. It's there. You could maybe draw from it if you had a medical emergency or something, you needed some money, you could take some money out. But for the most part, that's in this investment account that I'm not really going to touch. And then we have kind of this cation exchange sites here, and this is kind of like our checking account. All right, if you need money, you can't just go to a store and be like, I got $4,000 in my checking account today, so you need to give me this, right? You still have to give them money. And that's kind of then the soil solution. So we can grab money from our checking account and put it into our wallet pretty easy. You go to an ATM machine or you pull out a debit card and you run it on a card or something. So this is a pretty quick transaction. If I spend a lot of my money from my wallet, I just go and get more money from my cation exchange sites. So to go from kind of the investment side to what we can actually spend in our checking account, that's a slow process. But this process of going from kind of the checking account down to what's in our wallet, that can be much quicker. So going back to the plant analogy, if the plant's taking up potassium, what happens? The potassium from the cation exchange sites can then come in and can replace the amount in the soil. So if you have someone that's just looking at this, what's in the soil solution, they're missing half or more of the story. So just to do a saturated paste extract for a soil extraction doesn't make any sense because you're forgetting about what's in your checking account. That'd be like saying, how rich are you, and looking at your wallet and you're seeing how much cash you have in it. That doesn't tell you how much money you have in the bank. right? So if we're doing our soil testing, we have to think about this and what's in the solution. So we're going to go do our testing, some keys to success. You know, get a representative sample, use a proper extractant that's good for turf. And so we love the Mehlich 3 because we have the best interpretations of what those numbers mean. And it's also the most pH independent of our tests. So you can do it at a pH above 7 or a pH below 7 and still get pretty good results from the Mehlich 3. And then, you know, choose a test that we're going to have a good calibration method for. So we'll end with that. So when it comes to sampling, one thing I wanted to just kind of talk about, again, representative soils. If you have a site with very different soils, treat them differently. Measure them differently. So you know, okay, this area over here maybe doesn't need that much potassium because it's got a lot. This area over here maybe needs more potassium, so I'll adjust my fertility. So be representative in those areas. And when it comes to how deep, sample to where your roots are. We like to say to sample between 10 and 15 centimeters. 10 is really kind of standard sampling for stand-based, you know, putting green type turf grasses. So, and then stick to it. And this is why it's important. Here, I did a quick demonstration when I was doing my master's degree in which we took samples and we sent them to the lab with different depths. So it came from the same different spot on a green where the nutrient levels are about the same. And if we only did 1-inch sampling, so 2.5 centimeters, look at how much phosphorus was in that sample. 200 parts per million. If we did a 2-inch sample, so a 5-centimeter sample, that number now is 138. If we did a 6-inch sample, or 15 centimeters, now that number is 74 parts per million. So if we're trying to gauge from day to day, if we do maybe 3 different soil samplings over the course of a year, but we're varying our depth all the time, you know, it's impossible for us to compare as our number's gone up or have they gone down. So stick to a sampling depth and try to stick to it as best you possibly can. Oops. So how about the extractants? So again, we're going to send our sample out to the lab, we're going to grind it up, we're going to add this chemical to it, we'll shake it for a while, and then we'll see what's there. We really like the Mehlich extractant, again, because it has an acid in it, it has a fluoride molecule in it. It helps to get all the nutrients that are in the solution, but then they're also on those cation exchange sites on the outside of the clay and the organic matter, and it also can break off the phosphorus that can bind really tightly to the soil. So we can get a rough idea of how much phosphorus is available to that turf. So what happens here, if we have our soil and we have some nutrients floating in the soil solution and we have some more that are bound to the clay or to the organic matter in that soil, we come in with our extractant and we displace all those nutrients, and then we put this into a machine and we measure it. So this is an actual result. It's quantifiable. It's a lot more difficult to argue, you know, the number. So this is what we're looking for in our test reports. We want to find the results. We want to see what the absolute number is. And so that's either going to be usually in parts per million, or a lot of times you'll see it also in pounds per acre foot, or per acre too. So how do we make sense of these numbers? What are the things we need to do? Without some type of a calibration, these numbers really are useless. I mean, if I just shoot a number out at you and said, your magnesium level is 200 parts per million, is that a problem? I don't know. Maybe. Maybe not. Right? You don't know. So what we have to do is we have to then look at areas where we had magnesium at 200 parts per million, and then look at the performance of that turf and figure out, you know, was that too low or not? If it's too low, then we might have some reduction in the quality of that turf. It's not performing the way it needs to. The growth is going to be suppressed because there's not enough magnesium to sustain that growth rate. If it is sufficient, then the grass should look fine. It should look like any other grass area. So we need some type of way to calibrate these tests, and we do this through interpretation. And so again, this is a lot where the different labs, the different soils consultants, different faculty members are going to say, like, you know, this is the number I think you should shoot for. So there's kind of 3 different methods of doing this. The university recommendation is the sufficiency level of available nutrients, and I'll show that in a second. Then a lot of consultants and labs like to talk about the base cation saturation ratio. And more recently, with Micah and Larry Stoll at PaceTurf, and a lot of researchers too are also supporting what they're saying, we're going to the MLSN type of an approach to trying to understand what do these numbers mean. So let's just kind of talk about them really quickly. So kind of this SLAN, the sufficiency level of available nutrients, how's this derived? Well, you got one soil, so that's the first problem. It's specific to only one growing environment, one soil, one plant species, one environmental set of conditions, right? One fertility rate. And then you had that site, you might do different levels of a nutrient. So say we're testing for potassium. We could have the soil going from 1 to 400 pounds of potassium were applied to that soil as a fertilizer, and then we have some type of response. So I'm from Nebraska. It's a big corn country. They're the corn huskers. And so they'd have the number of bushels per acre of corn. How much corn am I getting from that land? And so from that, we say, okay, how much potassium fertilizer should I apply? If you look at this, we're seeing the more potassium we apply, I get more and more bushels of corn, and then all of a sudden at about 200 to 250, I don't get any more, and it's flat. So you might say I want to apply between 150 and 250 pounds of potassium. This is where these kind of these labels of low, medium, and high start to come in. So then some guy like me just comes and says, all right, we'll call these low, we'll call those medium, and we'll call those high. Or maybe we'll call this optimum and this high. Or we could say maybe this is optimum and high would be if you put down so much potassium that you actually saw a reduction in the growth rate from all the salt from that fertilizer that the corn yield drops. That might be high, and we might call this optimum. That's where this comes from. But again, it's specific to one very specific area, one soil, one grass. And so that can be kind of a problem. So we can do this for phosphorus or potassium or calcium or pH or anything. But again, applying it to a broad area can be kind of problematic. So another issue we have is how do we do this in turf? It's easy in corn or in soybeans or a commercial crop or rice because you want to know how much yield am I getting off of that area. But in turf, it's less clear. How do we calibrate these tests? Do we do it based on growth rate? Maybe, but we don't really know what a good growth rate is for turf grass, so that's kind of a problem. So a lot of times look at the quality. How green is the grass? How well is it performing? It's subjective, but that's how we're managing our turf. We're trying to make the grass look good, so we use that a lot of time. So here's a study I did with phosphorus, just to kind of show some of the results and how this actually works. So this is a SLAN interpretation to figure out how much phosphorus is required for this green. And again, it's specific to this bent grass green in Madison, Wisconsin on the straight sand in Madison, Wisconsin types of weather under a certain type of nitrogen fertilizer rate. So we have different levels of soil phosphorus, and so the plots that look really bad actually kind of look like wilt. But if you see wilt and you put water and you measure it and it's wet, and you put down nitrogen fertilizer and it still looks like it's wilted, check for potassium or phosphorus, because this is what happens a lot. So we'll see 3, 4 parts per million. This is pretty much pure sand. This is really, really, really low levels of phosphorus. The old university SLAN recommendations would say you need to be about 50 parts per million, and we're down at 3 or 4. So you would expect that this would look kind of bad. But what happens if we increase the level in the soil? So if we go up to 5 parts per million, still 10 times lower than the traditional university recommendations, the grass is looking a little better. There's still some purple there. It's still not perfect. Increase to a 7 parts per million of a malic 3, and there's no deficiency anymore. All of a sudden now the grass looks perfectly fine. And if I put down more, so I got 17, 20, if I had 100 parts per million phosphorus, the grass looks fine. Because I've now satisfied its demand, its growth demand. But again, this is specific to one type of a growing environment. So on this particular green, the quality increased, and when I had 7 parts per million, I had great quality, and anything above that, I had no more increase in quality. So in order for me to try to apply that to the whole world, I go, okay, well, let's real scientifically, let's multiply it by 3. So we say, okay, how about 21? That seems like a good number, right? But that's where the interpretation part gets a little bit, squealy. I had to say, okay, let's multiply it by 3 so we can try to cover all our bases, and that seems like a good, safe number. And we'll talk about, maybe how that could be problematic. So then another way we could interpret these numbers, and maybe not for phosphorus, but for things like calcium, potassium, magnesium, sodium is to look at the exchangeable percentage that's there. How much cation exchange is a result of those different bases. And so we'll talk about that for a second. So again, this is our soil, and the cation exchange capacity, again, that represents these salts, the calcium, the magnesium, the acidity, the potassium that's on this. So if we added all those up and then looked at how many of the total amount of charge elements are there from calcium or magnesium or potassium, the concept would be then you'd want to have some kind of an ideal level in that soil. So this ideal soil concept came up about 100 years ago. And so they said, the first lab that tested it said, you need to have between 65 and 85% calcium, 6 to 12% magnesium, 2 to 5% potassium, and the remainder being ammonium, acidity, and less eating sodium. You want 0 sodium would be ideal in a native soil environment. It was quickly shown to be incorrect, though. It didn't really apply anywhere. So they tested this out in turf, too. And they found the same thing. When they were growing grass in different levels, different ratios of calcium and magnesium and potassium, all those different red dots, the blue dots show where the tissue was. It's very tightly clustered around one different level. And why is this? Again, because the plant is controlling uptake. So to have this approach, you completely ignore the plant. So the kind of analogy I like to use would be, if I'm hungry, I'm watching golf yesterday, and I was watching Tiger almost win. And I'm hungry last night, and so I go into the hotel minibar, and if I wanted to have a candy bar, and I wanted to have, a donut, okay? If I go into that minibar, if I wanted 1 candy bar and I wanted 2 donuts, as long as there's 1 candy bar and 2 donuts in there, I'm happy. I've satisfied my demand for those junk foods. I don't really care if there's 800 candy bars and only 27 donuts in that fridge, because I only want 1 candy bar and 2 donuts. I don't care what the ratio is. As long as there's enough there that when I want to grab that candy bar or that donut, or when the plant wants to grab a calcium or potassium, there's enough there for it to grab, it's happy. So to sit there and focus only on the relative amounts of how much calcium the potassium is there, it doesn't matter. If you had thousands of parts per million of everything in a really fertile soil, and the grass only needs a handful, it doesn't matter what the ratio is. So to spend time trying to balance those nutrients is just futile and just a complete waste of resources and a waste of product. So if you look at our test report, that's the one you'll see here. So if you see like percent calcium, percent magnesium, percent potassium, and you see these numbers, and they tell you what it should be, just ignore it. The only thing you'd want to possibly look at is the percent sodium. If you have sodium in your water, that would be something you'd want to watch, and only on native soils. If you have a sand-based putting green and you have high sodium, I do not care. It's not going to affect the soil, because sand putting greens don't have they don't have compaction issues. They don't have clay. So sodium in the soil only affects the clay. So then, going back to the analogy I used before, where we had the slant level on my phosphorus putting green. And again, I said 21, and I said that's kind of a safe number. For that green, I researched when I had 7 parts per million phosphorus. If I had more than that, I was good. But again, I wanted to put some margin of safety in there, so I multiplied it by 3. So then what PACE and Asian Turfgrass Center, did is said, okay, let's look at all these different soil tests and try to take like a reference idea. If we look at what everybody's soils are, and we know that those soils all have good performing turf at it, then we can start to figure out, how low can I get in my nutrient level in which I start seeing a reduction in the quality of that turf grass. So this is kind of what they did. They had all these results. There's thousands of results. And again, they looked at potassium in the soil, and they grouped them in these different little pools. And then we figured out, okay, where's the mean, where's the median, where's the peak of this distribution here? And then let's figure out, how far back can I go in which all of a sudden I stop getting samples that are representative as good samples. And so they worked their way back, and they put a 10% number on this curve. So here's kind of our probability of the amounts of people having, say, malic-3 potassium or malic-3 phosphorus. And when they do that, when they put their 10% on there, they get a number of 21 parts per million. It was exactly the same as my guess at 3%. So this is a good way to kind of have like a reference of do you have enough of these nutrients? We're looking at all these people across the entire world that say their grass is performing well, and we see how much nutrient is there, and we say, you know, we start using that number to figure out where are you relative to the rest of everybody else. We do a very similar thing for blood pressure. If we take our blood pressure, we go to the lab and they say, okay, you're 120 over 80 or you're 110 over 60. Who says that's a good number? Well, doctors look at a distribution of healthy people and figure out most people average around 120 over 80. You can be higher or lower. It doesn't mean you're sick. It just means that's where you are relative to everybody else. And so it's a really nice way to kind of give reference to what your soil test numbers mean. Let's see how we're doing time. All right. You know, another thing that we like, we've really been focusing on too, is doing some tissue testing. Sometimes there are things, we look at quality, maybe it doesn't tell the whole story. And so tissue testing might give us some more indication on what's going on with our turf. And so here's a situation from Doug Soldat. Again, this is a cool season example. This is bentgrass putting green, but it's kind of showing some of the utility in what tissue testing can tell us. So we have the different plots here that Doug Soldat's fertilizing with different levels of potassium. This is the same green that I built for my phosphorus research as a master's student. So after 7 years of no phosphorus, the bentgrass tissue levels on this plot are less than 1.5% by dry weight. The plots that are being fertilized every 2 weeks with 1/10 of a pound of phosphorus, it still have pretty low levels in the soil, 35 parts per million. That would still actually be below the MLSN levels versus 20 parts per million where we're not putting anything down. And both grasses look pretty good during the growing season, no problems. But the tissue level then is up at 20% at when they're putting down 1/10 of a pound every 14 days. But it wasn't until we induced some type of stress that then we saw that there was an effect to, say, the potassium. I got it. Yeah, we're wrapping up. All right. So we have potassium at 2% in the fall versus 1.5%, and we see a lot more snow mold from that situation. Both have low levels of potassium in the soil, so this is where the tissue test is giving us some guidance on maybe some kind of a stress physiology type of response. Bruce Clark at Rutgers has been doing very similar work with annual bluegrass. Again, something I know you're not growing a lot down here, but again, it's just showing that there's critical levels for, say, anthracnose, or for the annual bluegrass to go through proper hardiness, that a tissue test is going to give us a better representation of than just soil test results you're going to give us. So, you know, how would I do it? How would I soil test? What's, you know, kind of an effective way? And this is kind of my opinion, but if I had to do it, I got a mullet nearly as bad as Micah in this picture during my internship. First, you have to be consistent in everything. If you're not being consistent, then honestly, don't even waste money on soil testing. If you're just doing different depths and you're testing different areas all the time, you're just wasting money. So you have to be consistent, using the same lab, using the same times, using the same depths. All those types of things are important. When would you like to do it? I like to do it in early spring. Why? Because if I am low on a nutrient going into the growing season, I want to know that going into the season. I don't want to wait till it's the fall and all of a sudden be like, oh, maybe I did want to put more phosphorus down last year, right? And then if you get a lot of snowfall, a lot of rain in the wintertime, then you're going to lose nutrients. You're going to leach them out the bottom. So that's another thing you might be worried about. Where? Representative soil areas. So if you have 18 or 20 greens on your golf course, a big trend is you do 6 greens a year. So maybe you do, you know, greens 1 through 6 one year, and then 7 through 12 the next year, and then you do the remainder in the third year. I really don't like this way. I think maybe do that once. Find the greens that are kind of average for all of the greens. So maybe you know greens 2, 8, and 14 are always they're kind of in the middle of the pack for all the different greens. I would sample those greens every year and then see if the numbers going up or down. If they're going up, well then maybe I'm putting down too much nutrient, too much phosphorus, too much calcium, too much potassium. If they're going down over a year or 2 or 3 or 5, then I'm not putting enough of those nutrients. Maybe I want to put some more, as long as they're at a level that I'm happy with. So if your happiness level for phosphorus was 50 parts per million, and at year 1 you measured it and it was at 80 parts per million, and then at year 5 it was at 60 parts per million, you got to think, I got to put some more phosphorus down so that I don't drop below my 50 parts per million. Again, be consistent. Most of our calibration has been done at a 4-inch depth or it's a 10-centimeter depth, so be consistent with that. And use a lab that you can trust, that they have good methods that are repeatable, so your numbers make sense from time to time. This is something that people don't always ask and think about, but you need to know. I know this name is really weird. Malick is not an easy name. It's like Kreuzer, right? It's a really bad last name. But it's the name of the guy, he invented the test. This is something to ask for. You want the Malick 3 soil test result, or extractant. Because then we can start using the MLSN and the university guidelines to make sure that we know what the value has to be. And so if we're consistent then, now we can start monitoring what's happening over time, and we can use it like looking at bank statements. If our bank statement shows that our money in our bank is going down, 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 down over the last couple of months, you're probably spending too much money, you need to make some more money, or you got to spend less, right? Now we can start using it as a tool like that. All right. I think we'll end there. So we'll take a little break, and then we'll get back into it after 15 minutes. So 15-minute break. What time is it now? We got 10:28, so 10:45, come back in, and we'll get started back up again. Thank you.
Okay, guys, just an announcement. 15-minute breaks, please be on time. And also, for those of you who needs a certificate of attendance, please check your name spelling at the registration table by today. Once again, if you guys need a certificate of attendance, please check. If you haven't done so this morning, check your name for spelling so that they can proceed with the printing of the certificate. Okay? Coffee break right outside the back door there.
Well, one more thing for our delegates who require some receipt. So now we got some problem about the address database. So please inform your update address and names at the